Okay, let's go ahead and create a new project. Hit create, and I'm going to use the mobile renderer. I'll browse and save it to anywhere I want. I'll create a new folder for this. We'll call it the tower stacker, and we'll hit a new project, select current folder. We'll name the project tower stacker as well, and I'll just name it tutorial. Okay, hit create to create a new project. Okay, now let's create a new 3D scene. I'll name it the game scene or main scene, whatever you want. I'll add, if you click these dots, you can preview the sun and the environment. You can make minor changes. I wouldn't do that. I would just add the sun to the scene just for the lighting. Then I'll just add the environment as well. You can see you click these buttons and now the environment is in the scene. I can just go to this, and for the background I'm just gonna use custom color right here, or you can just use a sky. I like to use gradients for a background. For custom color you can only set one color, so you can just select something like sky, go to the sky, create a new sky, click on it, a sky material, create, I don't know, panorama sky material, and then the panorama I'll just create a gradient texture, 1D or 2D, doesn't really matter. Gradient texture 2D is better. We can go ahead, and I want to make it go bottom to up, so just something like this would be alright. So this, I'll give it bluish, pinkish, whatever color. I'll give it a bit of a purple and a blue. Wait a minute, I'm gonna give it a purple color for the bottom, and I'll go to the second slider and select this, and I'm going to change this color to something like a bluish, something like that, which is a bit distinct. This should work. And we get environment. Keep in mind that these grids do not render, so if you're visualizing something, it's a good idea to kind of add a camera 3D node, and you can preview what your environment looks from the eye of the camera right here in the inspector. Once we are done with the environment though, we should go ahead and place our camera wherever you want. For now I'm just going to place this in kind of, if you see it from the top view, you can see this is the middle, and just want to have a isometric style. We want to have it from a corner, so I'm gonna bring it here, I'm going to rotate it. I hope you can see this, it's being rotated right here, and I'm going to make it look toward the center from a kind of an isometric perspective. Then I'll rotate it on the local axis. Right now it's working in the global axis. If you click this object button here, it's gonna go into the local space for rotation, and I'm gonna rotate it a bit down, and then I'll switch to the global axis and put it here. Right now it's looking at this right here. Since there's nothing on the center, you can't really visualize what it actually looks from the perspective of the camera, but we can change that later. Let's go ahead and start working on our game. Let's start by creating a new scene, which is a block scene for our blocks that will stack. We'll name it block or whatever you want. Naming is mostly just for remembering. If you can remember what you name an object and can change based on that, you can name your objects whatever you want. I'm gonna name it block. I'm gonna add a mesh instance node. Mesh instance 3D node. Keep in mind you can or cannot create a mesh in here. It really doesn't matter. We're going to be doing that inside code, so you can add one here, and we can that's just for visualization. So anything that you see in the block scene here doesn't really matter, even if it's, but only the position of these nodes should be in the center, so it'll make our life a bit more easier. Control A to add our collision shape node. This is mostly just for future uses and mostly wouldn't be used, but in case you want to turn this into rigid body fold and sort of collisions, it's a good thing to add a collision shape. Again, the shape or size of the collision doesn't matter. You can assign any resource to it, that doesn't matter as well. This is just for kind of a visualization. Again, the material also doesn't matter. Now let's go ahead and go to the scene. So game scene, I'm going to save the scene as the game scene. I'll create some folders for scenes. Again, we'll create a new folder for creating our scripts or our code. I can just name it code. I like to do that, but it's more professional to name it scenes. I don't know. You can throw your game scene inside the scenes folder, and we'll create all of our code in the. Also, we'll go to the block scene and save it in the scenes folder. Next, we'll go ahead and create a script for our block. Make sure you save it inside the code folder so everything is quite organized. You don't need to use that template here, so just go ahead and create. Here we are in our 3D script. It enhances for no 3D. Make sure you remember everything here, and let's go ahead and start code. We'll start by creating a variable called width. We'll do the same for things like height and depth, and we got width, height, and depth. These are for our block, so we can decide how long, wide, and I don't know, length it is. Okay, so let's move on. To decide which axis our block will move, we'll make our movement axis node. I'll initialize this to x. That means when the game starts, it's gonna be moving on the x. You can do it on z. That's just totally your decision. What we'll do is we'll create a new variable called mesh underscore mesh, and we'll set it equal to these nodes. First of all, our mesh. What I'm gonna do is I'm gonna rename this to mesh, and again we'll name this to collision, and I'm gonna access at unique name. This will make it kind of a unique, so this way we'll be able to access this without kind of knowing the exact path to it. Again, we'll create a variable for collision as well, which is going to be this underscore collision. Then we'll go ahead and create a new ready function and call this non-existent update mesh function. We'll create this update mesh function so it can exist now. So now in the function we'll do this. We'll create a new variable called box. Now this box will act as our resource. Now what resources are these stored kind of different kind of data. So for example, this mesh, this uses this mesh resource, the mesh instance really. This mesh resource stores this block or any sort of mesh, its size, its material, and everything like that. So we'll create a new box mesh, which is this is a box mesh. If you right here, you can see this is a new box mesh. So we'll do this, and dot new means creating a new one. And in the box mesh dot size, which is the size property, if you see here, which is vector 3. Vector 3, that means that it has 3 values of x, y, and z. You can see these are x, y, and z, and we'll give it the width, height, and depth, which are the x, y, and z values. Then we'll get our block or our node, and in the mesh property, that this, if you see here in the inspector, this is this block's mesh property, and we'll set it equal to the resource we created. See, this already has one, which is a kind of a placeholder, and when the game starts, we're just gonna set it equal to this one, that one we have created, just the box. And this way we'll have our box mesh, a mesh which of this width, height, and depth, and this way we can just create it and customize it and manipulate it in the code. Any properties we set here will be this way we'll create unique meshes. We'll do something similar with our collision, which has the similar properties. We can see we'll just create a new variable called box shape, which is going to be the property. You can see shape, box shape. You can see this is the property, which is the shape 3D property, and we'll assign it a box shape. You can see box shape 3D. This is a name, box shape 3D. We'll make it a box shape 3D dot new. That means creating a new box shape 3D, and we'll just take the variable. We'll customize its properties. Its properties is the size property, which will set it equal to the height, depth, and width variable. This way, the collision and the mesh are both the same. Then we'll reference the collision. As you can see, we can just reference the variable, or you can just directly reference it like I did before. So we use this variable which has the reference to this object. So we just go ahead and we shove the shape property, which is right here, and we'll set it equal to this resource we created. This way, this will now have the collision of this height, width, and depth, and we can customize any more properties here. We can like do disabled. You can just literally customize any properties that this has. For example, you can just call it underscore collision, and dot this property is called disabled. You can right here and search for disabled, I don't know, disabled dot disabled, and we'll set it equal to true. This means it doesn't work now. which we don't want. This is just an example that you can change any kind of properties that this has in the inspector, or you can just kind of find more in the documentation. And yeah, for placement purposes, what we do is we're gonna get the underscore mesh and dot transforms. I'm gonna set equal to transform 3D, and this is a constructor of transform 3D that takes the basis and the vector 3 or the position kind of thing. Now we're gonna do is for the basis, we'll just gonna go basis identity, which means it has no rotation, no smear, or no scale. So it's kind of like identity is kind of like for 0 0, or you can just call it 1 0 0 0 1 0 0 0 1, or so it's kind of a short for Godot has this like vector 2 dot right, vector 2 dot up. So it's kind of like vector 2 vector 3 dot identity is like kind of for 0 0 0. It's kind of a thing. So again, we'll just pass in the vector 3, which is going to be vector 3 0 height multiplied by 2, and then here 0. So this is the transforms. So it's just kind of places on the y0. It's good for doing when we'll align things and compare if things are aligning. It's gonna be used for that. So now awesome, we have done the things for updating our mesh. Now we're going to create a new function. This is kind of a useless stuff, but really cool, which is the color. Now you have seen the tower stacking games. What it does is we'd have different variation of blocks. So whenever a block spawns, it has a different color than the previous one, so kind of to create a distinction. It looks beautiful. So what we're going to do is I'm going to create this set color function. We're going to give it this hue, which is a float. We'll change later. And well, what we'll do is we're gonna use this to create a color variation for our block. Just like before, we're gonna go through with the same process of creating a variable, then assigning it equal to our resource, then again using the variable's name, customizing the properties of that resource. This is a simple pattern that you can repeat to create custom resources and update their properties, to do things like change anything through code. So this is something that you can kind of set pattern that you can learn from. So we create a material 3D resource. .new means creating a new one. So every time this node is instantiated, or instance of or a version of this block is spawned, it's gonna create a resource for itself, which is gonna be the standard material 3D, and then which is I'm gonna name it mat or material, kind of a short for material, and which is gonna set the albedo color. Albedo color is literally color. I don't know why they just call it albedo. It's just the color of the skin. And when I set it equal to color is like color dot from HSV. We can just give it a vector 3 or 3 values, and it's gonna from the HSV slider. So first is H, the hue, V is the HS is the saturation, and V is kind of the darkness value. So for saturation, we wanna keep the saturation consistent, but for hue, we're gonna wanna change this or randomize this to get different colors. So saturation will stay same, so it's gonna give us same kind of palette, because if the saturation is same for all of them, it's gonna look similar. A simple design choice. You can randomize this as well. So now of course we do wanna assign this material that we created to our block. So it's kind of a test for you. You can just test how you can do this. How we do this, we just take the mesh underscore mesh. You can just call the mesh, and you can use a function called the set surface override material, and which takes two values, which is z0, which is if you hover with it, it's gonna tell you we're gonna give it the surface and the material. So we're gonna 0 for the surface, so it's the literal surface, or there are multiple things, so, and the material, so 0 for the surface and material, the mat, and it's gonna set the material we created to our mesh. So the thing I want to teach you is that instead of relying on me or any YouTuber to find you all of these functions or properties that I'm pretty sure a lot of you haven't seen some of these properties, and you're like, oh yeah, what the hell is he writing? How the hell am I gonna use it in my code? The best way is to repeatedly learn something. That's why I'm using this method a lot. You can see this is a pattern. This, and this all are the same. Just creating a resource as a variable, then customizing its properties. Just creating a variable, resource, customizing its properties, and you can just use that variable to then assign properties. So you can just literally go into a class in the documentation. You can see Godot has amazing documentation in game. This is offline. You can access it as whenever you want. And although the information is not quite beginner friendly, to be honest, I don't know what's this 3D 3x4 means. I know what it means. So basically you can just go through these recommendations, learn about new functions. You can just find, you can see this name tells us that is used to override the material. Simple things, just have to go through the documentation. Use your brain, kids. At the end, I'm just gonna create this function, which is the duplicate block function. I'm gonna use this to help me out. It's kind of a helper function. It will help us duplicate our block. So whenever things like we wanna get a block, since we're gonna be changing properties and stuff, we wanna have a duplicate of a block. We can use this to create the following pieces and all that kind of good stuff. So instead of writing all of this code again, we can just create a function, and we can do this again. Really nice stuff. We can now just save this, the block code.tcn in the scenes folder. I don't know if, and we got this block tcn. I'm just gonna override it, and the block gd as well. And now go to the game scene, and in the game scene 3D, you can in Control S, save this. I'm gonna create a new script. I'm gonna save these scripts in the scenes folder. I'm gonna create this game.gd. I created one. I'm gonna open it up, and I'm gonna load this. And we got this game.gd. It's gonna extends node 3D. So, node 3D. It was a corrupted file. I corrected it. Okay, so oh shit. Okay. We're in the game.gd. Now we need to create a bunch of variables. First of all, we're going to create the start block width and start block depth. So this is going to be for the starting block. This block will kind of tell us it's a start block. Of course, the game will start with one block, and it's going to be, this is the values for those. And we're gonna go ahead and create a bunch more variables. So let me explain them one by one. So the block height, again, this is the height of the block. Since this won't change, this is again, and we got the move range. This is for how, since the block is going to be going, the block that the hovering block, the moving block is going to go left and right. It needs to have a range, how far it will go. This is the move range. Of course, we got the base move speed. Since it's gonna create again an increase by the difficulty. This is the base value. Then how much value should increase per level, how much value should increase per level means after placing a block, the next level. The perfect threshold is kind of since we're gonna giving the player kind of a feedback if they plays perfectly and not gonna be cutting the blocks. So what we're gonna do is we're gonna give them a little bit of a threshold. So how much is kind of forgivable, how much if it's a little off, if it's 0.06 off, it's okay. And then we have the minimum overlap to continue. So this is like the minimum value. So this is so if the block has barely touched, and we're gonna visualize that. So it's kind of like to visualize the minimum amount of block that needs to be left for us to continue playing. We're gonna understand that when we create the game. So next we need the block scene. So we're gonna get the block.tcn, and we just need to go to the scenes, and we just to correct this reference. Good way is just to create this variable, then drag and drop it here, and hold control before leaving, releasing, and this is going to be creating a preload reference. Then we'll need to create some more block objects here. I'm gonna go into the inspector in the game scene. I'm gonna control A. I'm gonna add a node 3D, and I'm gonna call it the stack root. Stack root is kind of the root block that will hold all of our spawn blocks. This is a really easy way to kind of organize. Then we'll have the 3D again, just to organize, and we're gonna call this moving blocks. Moving block. The moving block will be the child of this. And for future, I'm gonna create a canvas layer node for displaying our GUI. We will create the HUD, but later we'll set up the code for HUD right here, and then later create the code for things like restart menu and score and all that kind of jazz. Moving on, we also when I reference all of these, you can see the HUD. Right now we don't have the HUD, so this is going to be kind of a empty reference. Or what we can do is just create a new scene, and it's going to be the user interface. I'm going to call it HUD GUD, and I'm going to save this in the scenes folder. And in the game scene, we're gonna append the HUD scene here. I'm gonna change this so everything from the root type to everything. This is just so the reference is correct. So we get the canvas layer.HUD. Then of course we're gonna have the camera to 3D, which we did create. So we already have it, and we have it on place. So we all the references here. Make sure the names are correct. And yeah, that's gonna be it for the references. Then we're gonna create some more bunch of variables. First off is well level. This is to store which level we are on, not the game levels, the level height level. Score. Then we've got the direction. Current block, which is a no 3D is equal to null. We'll use this. Last block, we'll use this to compare the size of the last block, so we can create the new block on the same size. Game over. Boolean equal to false. Right now not game over. Move time and camera target Y. Okay, so after all of this, I'm gonna create the ready function. Here I'm gonna do is input.set mouse mode to mouse mode visible. So just to make sure if the mouse is actually visible. This is a good practice to do in ready functions. Then what we're gonna do is we're gonna go ahead and we're gonna just call the non-existent start game function. So whenever the game starts, we're gonna start our first game. This is a good thing. I mean, we're just gonna start the game right away. You can use a main menu. I just want to make game start the game right away, or you can just use a button and then call this function with this button, whatever you want. A good thing to have this kind of functions. I'm gonna create the non-existent start game function, so it now exists. In here, what we're gonna do is we're gonna start by clearing the nodes in the stack root. Now stack root will contain the blocks that we're gonna spawn, so we want to make sure when the game starts there's no blocks here. So we're gonna get the stack root, and we're gonna get all of the children, and we're gonna queue free all of the children. So we're gonna remove all of these children. Again, we're gonna do the moving holder or the moving blocks. I'm gonna get the children and gonna just remove them. So this will kind of make the games clear when it starts. Then we'll initialize all of these variables here for starting the game. So here we'll set the level to 0, so score to 1, direction to X, current block to null, and all of these values. So kind of like the values for start. So when the game starts, it's gonna be these values. Now I'm going to create the base, which is the block scene. What we're going to do is var base block scene dot instantiate as no 3D, just to make sure it's a no 3D, and then we customize all of these properties here. This is for one block, the base block, the block that's going to start the game. So we need to do it one time. We're going to set the name to base, just so the blocks created, so we can just access it, so we know that its name is base. We're gonna set the base dot position equal to vector 3.0, which is that means it's on the center. Then again we're gonna set the width. If you know, it's the value or the function we created. Set width, which is the variable we created in the blocks here, right here. So it's gonna set the width here, and we're gonna set the depth with the start blocks. We can see the values we created up here, and again we're gonna set this the start blocks height, depth, and blocks height and depth. Then we're gonna call the call deferred, which is let us it's a function that let us calls the method and returns null. Then we're gonna the update mesh function, set color, and this set color function we're gonna pass in the hue value since we gave it as a parameter, and I'm gonna give it 0.55. and stack root we're gonna add children base, and for the value variable last block we're gonna set it to base. All of these will help us create a base block. Now in the 3D scene, if we just go here and run the scene, you can see that sometimes this is literally Godot's problem, not mine. I'm telling you this. So you can see invalid assignment of property shape of value box type box shape 3D on null instance. Now what it's saying is that this collision, this thing that we are setting, this shape property, and this is not collision shaped 3D, which it is. We have given it the reference, but the problem here is that somehow due to some Godot magic problem, it's not catching the reference. Reason for that, sometime it's Godot's fault and sometime it's our fault. Why it happens is kind of a bug. I've reported it. I don't know what happens, but last time when I was trying to do this, it just magically didn't happen. This time it was my fault. I know this because I didn't make this access as unique names, but it is something that I want to tell you that sometimes Godot doesn't catch reference and you will have to restart your project or just save your scene or just reload stuff, and this thing sometimes happens. Okay, so make sure that your references are correct, but it can be Godot's problem. If you are like fully sure that everything's right, then it's a teeny tiny possibility that this is Godot's fault. This is something I just wanted to tell you. Let's run the scene, and now we have a base block. This is the block we will start the game. This will tell kind of the player to which block we should align the coming blocks on. Okay, now awesome, we have our first or ever game. Now in this function, for the last thing, we're gonna call the non-existent spawn moving block function, and we're gonna immediately start and create this function and start working on. We're gonna create this function, so it's no longer non-existent, it exists now, and right off the bat we're gonna check if game over, then we're just gonna return. So check if game is actually, we just literally game not over. We're gonna do is we're gonna call current block is equal to block scene dot instantiate as no 3D again. Then we're gonna do is block name equal to block %d %level. This will give you each of them unique names so we can actually access those names and assign them properties. It's a good thing to name those things. Now what we're gonna do is we're gonna set the size of this new block. So we're gonna set the left LW, which is the length or left wide or whatever. So last block, if you remember, we set the last block to base, which is going to be the base block. So we're gonna get the last block. I'm gonna get the width again, the LD. We're gonna the last block get depth. So this way it's gonna the new block that spawns is gonna be the same size as our previous block. This will make the gameplay work. Then we're gonna do is we're gonna go current block, which is the new block that's created, and we're gonna set the width property to this variable, and we're gonna do the depth properties to depth. So last width LW, last width, LD, last depth, last block's depth. So it's got a short name, I don't know. Now since the height actually stays consistent, it doesn't go in the gameplay, we're just gonna set this to block height, the variable up here. Okay, so this way there's no kind of problems. So we could just take the length or height of the last block as well, but it's not needed, unnecessary processing. So we just got the height, and that's kind of it. Now we do have assigned the variables, but we actually need to update it. So we're gonna call the update mesh function of the block. So we're gonna use the call deferred again, and we're gonna call the update mesh function. The call default is kind of a cool thing. I kind of like it. I don't know. So we're gonna use make sure the naming of the function is correct. Oh my god, you're gonna be in trouble if you forget this naming. Gosh. Now for the color BS, we're just gonna do this. We're gonna create the hue. We're gonna create the variable hue, and we're gonna use the f mode function. This is some sort of magic function. I fully don't understand. It just takes and to be honest, I just took this from someone. So basically it's just whenever the level changes, it's gonna add. So we got initial value, so we got the initial value, and it's gonna just add the level. So if level is 1, the level is gonna be 1, that's 2, 3. It's kind of a trick. So it's gonna just change the color. What you can do is you can also randomize it. I just like to kind of mutate the colors to a different color. So it's gonna keep adding 1, 2, 3. This way what will happen, and we're multiplying it to 0.03. It's kind of keep a color and 1. So it basically just moves this through adding this value and turning this into blue. I'm not really good at color numbering. This is something that I'm really bad at, knowing numbers of colors and values. So this is just me going on Google. So this is something you should take a bit of advice from someone else, or Google it yourself, or ask AI or something. This is something I kind of lack the explanation. Then again, we need to call the set color function to actually update the color, and we're gonna give it the hue value. Okay, and this way the color will be updated. Now after doing all of these preparations, we actually add the moving holder, which is the this moving block, and we're gonna add a child, the current block, and we're gonna add this as an instance, since we have instantiated it as block scene, block current block, and so it's gonna add the. Now what we're gonna do is this. We're gonna create a variable called base world. We're gonna set it equal to last block dot global transform region, which is gonna be the center of this world, the last block, which is the base block right now. Then we're gonna create the start world. I'm gonna set it equal to vector3 base world, which dot x base world dot y and block height. Then I'm gonna do is current block dot global transform equal to transform 3D basis identity and start world. Now what this basically does is let us use the global transforms safely. This will literally just align the newly added block on top of the existing block. Then what we're gonna do is we're gonna set the current block's move axis to direction, which is x. So which axis does this block actually move, left or right, or up and forward and backward? I don't know. In the x or the z axis. So this way we can alternate. We can, sometime it's gonna be left and right, sometime it's gonna be backward and forward. Then we just do is we add 1 to level. So every time a block is added, the level increases, and we're gonna set the move time to 0.0. This will just tell us that it's on the center. And yeah, there we have it, the moving block code. We can just do this to kind of make this short. I like to do this to kind of don't overwhelm me. We can run the scene. There's gonna be errors. You can see right on top of this is the block. We haven't actually moved it. We only spawned the moving block. We're gonna move them. We're gonna move it. But you can see now we have a block, and it's gonna have a color, which is this yellow color. We can give it any color we want, literally. This kind of looks cool. And now we have another block. We have this moving block that we have spawned it. We need to move it though. Now let's actually move the block. We'll create a new function, which is the move current block. Keep in mind all of the code we written here is right here. Just get the drop down here. So we'll now move the block. Right off the bat, we'll check if there is a current block or last block. If either of them don't exist, we're just gonna return. Okay. Next, we'll create a variable called speed. This is gonna be the speed of movement. We're gonna the move base speed, then we're gonna plus the level. So this way will every time with the level the speed will increase, level multiplied by increase per level. So for every level it's gonna multiply it, so it's gonna make it faster every level. Then we're gonna create a variable called offset, and we're gonna make it equal to move range multiplied by sine. This is the sine function, and we're gonna inside the function time movement time multiplied by speed multiplied by 0.6 plus level plus 0.5. Crazy math. Then what we'll do is we're gonna call variable base fold equal to last block dot global transformer region. This will just all of this is kind of to ensure that the block, that new block that spawns, is moving on right on top of the existing block. And this is the target world equal to the current block dot global, and this again. So all of this is literally just using the same sort of concept, just setting it to the so the origin of the new block is the last block, not the center. Okay, so it's kind of moving in the reference to the last block to make it all centered. Now since we want the movement axis to alternate, one time it's moving on X, one time it's moving on Z, we also want to change these values according to that. So if current blocks dot get move axis is X, then a target volt dot X is equal to base volt dot X plus offset. Target volt dot Z is equal to base volt dot Z. Else this. Target volt dot Z equal to base volt dot Z plus offset. Target volt dot X equal to base volt dot X. Okay, I don't know what. Then we're just gonna do the same thing we did before, kind of to center this stuff. Target volt dot Y equal to base volt dot Y plus block height. So target volts. So we're gonna the target dot Y, which is the height or the Y position, is gonna set this to the base volt, which is the base, which is center, plus the block's height. So this way we'll set the height to, it's gonna make it stack on top of the previous one, so it's gonna make the height above. Current block dot global transform, and we're just gonna assign these variable values. We're gonna set the transform to the current block's global axis, so center on the current block and height on the target block. So this makes the current block move on top of the previous one. All of this is just to make sure. Okay, we should be able to see something. Yeah, not right now, I know there's some stuff needed to be done right now, and we haven't called the function again, so the function is just standing there. We haven't just called it again anyways, so we need to call that. For this we'll create the physics process delta function, and we'll do the rest of the processing in here. Again, we're gonna do is if game over, then we're just gonna allow restart when we drop the key. So if we press the drop button, it's gonna start the game if the game is over. We're gonna go to the settings, and we're gonna go to input map. I'm gonna create a new input. We're gonna call it drop the block, and we're gonna say add key, which is gonna be the space, and you can add the enter key or whatever you want, or the mouse click, yeah, whatever you want, and then we're just gonna return. So this will let us start the game, and then we'll just come back. Now what we're gonna do is we're gonna move time plus equal delta. So we're gonna increase the move time with the delta, and we're just gonna call our move block, which is the movement of our block. We can already kind of just run the game, and our block is moving. Of course nothing is happening right now, but the block is moving on top of the block. So what we'll do is we'll just call this input dot this is action is pressed function, and if drop is pressed, this drop, then we're just gonna pass for now, but we'll call the non-existent drop block function, which we'll create later. And let's just uncomment this, because we're just gonna go ahead and create this non-existent function which exists now. Oh my god, this is my pillow statement. Again, we're gonna check if there is actually a current block, and the game isn't over. So if not current block or game over, so both of them should not, have it. Okay, then we're gonna create a new variable what the WTS, which is the world trans. Okay, I'm gonna stop laugh. We're gonna do is if it should be in the function, yeah. So if current block dot get parent, which is gonna be every block is inside the stack root, so get parent equal to, which is equal to moving holder. So we're just gonna check if it's actually inside this move block or moving holder. Then we're just gonna moving holder dot remove child current block. What this will do is just gonna remove the moving block. So instead of actually just literally dropping it, we're gonna remove the current one and actually create another instance of it on top of the base block. Then we're just gonna do is just gonna call stack root dot add child. Again, we're just gonna and like add a child of this block, removing it and then adding it, and just gonna set the newly added child's transform to this current block child. I know, kind of pointless. Then we're just gonna create a variable info slice with last. So slice with last is a built-in function that will actually create I don't know why I said built-in. Slice with last is function that will create, and we'll use this to slice the overlapping non-overlapping paths, and we'll just give it the current block and the last block. Of course all of this will happen, and this is another function that we'll create later. I don't know, I should stop using non-existent functions. It's kind of a habit. Then we'll go ahead and say if info dot get perfect. Info is if it's literally on top of it, there's no problem. Dot get perfect equal false. Okay, then we're gonna do is current block dot set height, current comma last block dot get width, current block dot set height depth, last block dot get depth, current block dot call deferred update mesh. Then to animate all of this, I'm gonna create a new tween. I like tweens, and make sure it's here and like that. And for tweens, I actually got this tweening code somewhere again, I don't know. So what we'll do is gonna create a new tween, and which is this tween property, and we're gonna tween it with passing the current block, then scale the scale property, and then vector 3, and we're gonna pass in these values. This is to ease in and out. Then we're gonna set the translations or transitions, and tween dot trans sign dot set ease tween dot ease out. Then again we're gonna do this for the ease in, and chain tween DWP chain to tween property current block scale, pass in a value for tweening and 111 and this, and then we're just gonna set the transition to this. Okay, so if you're on perfect, this is what's gonna happen. We're gonna kind of like place it with this Q tweens, but if not, then we're just gonna do is we're gonna current block dot set width to this info dot remain width. What this does is it's gonna compare them and anything that remains, and the remain width and the remain depth. I'm gonna get the call deferred update mesh, so it's gonna set the mesh's size to the remaining of it, and then we're just gonna create a variable falling pieces, and it's just gonna be this vector 3 info dot falling size. Then if fs dot x is greater than 0.0001 or fs dot z is equal less than 0.0001, then we're gonna spawn falling pieces, and we're gonna pass in these values info dot falling world center, and then info dot axis. So what we'll just do is just gonna take the pieces that are not overlapping and gonna separate them into pieces, and then just gonna drop them push. Then I know it got a bit confusing. Okay, then we're just gonna update the last block equal to current block, and we're gonna increase one score. since we survived, then we'll just go ahead and camera target.y will just do this to actually move the camera to follow the higher towers. At last, we're gonna do this simple trick, which is gonna take the direction, and if it's z, then we're gonna set it to x. If it's x, we're just gonna set it to z. This is so alternate. So now let's actually work on the error of slice with the last function. Now this one is a bit tricky, so you'll have to bear with me. First of all, we create the function, which is this slice with last. We got this curr and previous, current and previous, no 3D, no, and it's a type. It's gonna display a directory, which is the slices pieces. Then we're gonna create this bunch of variables. You'll have to kind of wait, screenshot, or look at it by pausing this video, because this video is already getting really long, and I need to make this video into a reasonable length. So that's why I'm kind of speeding through the stuff here. So just kind of wait here and see this. So what we'll do is we're gonna this. If x is equal to x, then var diff, and we're gonna var diff is equal to wc.x and minus wp.x. These are variables we created up, and variable overlap is equal to pw minus abs, which is I'm gonna give it the diff. Then if abs, this is our existing function, you can of course just control click and learn more, and abs diff is greater than perfect threshold. So it's a kind of comparing if the overlap of the current block is smaller than the perfect threshold, then it is perfect equal true. Or we're gonna return the directory of game over equal false, remain with wp, remain depth pd, axis equal to axis, falling size equal to vector 3.0, and falling world center null, and perfect. So this is just so it will return that no, we don't need to slice, we don't need to fall, it's perfect. So now that we have handled perfectness, let's go with imperfectness. Then we're gonna do is if overlap is greater than or equal to minimum overlap to continue, that means we have sizable, we have sliced enough so we can continue. We're gonna return game over equal to true. So if it's overlap is smaller than, so that means the block, we stop the block from away from the base block. This means it's not enough. So we're gonna cut it, game over. Then we're gonna create remain w equal to overlap. That means there's nothing left. So kind of a game over. Then var new center x equal to wp.x plus div multiplied by 0.5. var new local equal to stack root.local, and two locals. So we're gonna convert this to the local axis, and we pass in the new center.x and wc.y and wc.x z. Then we're gonna create a variable called p for current position. I think I should get creative with these names. We're gonna get the current position, and we're gonna p.x is equal to, and then we're gonna px x is equal to new local.x, current dot position is equal to p, and var falling pc is w, which is the width, equal to cw dot remain w. Then we're gonna do this if falling PC's width is greater than 0.001, then falling size or x is equal to falling P's w, var s sine v is equal to 1 if diff is greater than or equal to 0, or else minus 1. Then var falling center x is equal to new center x plus sine v multiplied by remain w multiplied by 0.5, falling PC's w, falling piece w, which is width, multiplied by 0.5. I don't know. Okay, next we're gonna do is okay, next up, this is the code. In the else function, we're gonna do is var diff c and equal to wc dot to z, and overlap z equal to pd minus abs diff c. Then if abs, and in this function abs function, diff z is smaller than perfect threshold, then is perfect equal to, that means it's actually perfect. Up here kind of messed up here, so you can see if it's perfect true again. So it's like for both of the directions. So again we're gonna do the same thing, gonna sit on the same stuff. Now we're gonna do is if overlap z is smaller than minimum overlap to continue, that means game over. Then remain d is equal to overlap z, and all over again, that stuff all over again, just changing the x to z. And then we're gonna return the game over equal false, and again. So that's this way we're gonna slice them. So it's kind of like checking for perfect. So we have slice with last. Now we're gonna actually create the spawn, what the hell is the spawn falling pieces function. In this function we're gonna spawn the falling pieces. In this function we're gonna again create three variables. We're gonna variable which is the width, height and depth of the fallings. I'm gonna get the size dot x. If size dot x is smaller than 0.001, else then we're gonna get the current blocks dot get fit. So it's gonna just check if it's actually worth it. Then again same for depth, and height is always the same. Then we're gonna create the rigid bodies that's gonna fall. I'm gonna give it the body dot mass. Then we're gonna create the mesh child. We're gonna var m is equal to mesh dot instantiate new. Again we're gonna create a new instance for mesh. Then again for box shape, then we're gonna set the size to all these variables, and we're gonna set the m dot mesh is equal to the new box mesh we created. Again we're gonna m's position is equal to this. Again we're gonna create a new standard material. We're gonna set the albedo to, we're gonna take the same material and we're gonna assign the material. Then we're gonna create the collision with the same method, and we're gonna go to the stack root and we're just gonna add. Then we're gonna just place it in the world. We're gonna if full center, and we're gonna set the transform to the same trick, the identity, and we're gonna set it onto the center. Also you're just gonna set it onto the global transforms of the current block. Then we're gonna use this to add random impulse, RND, which is these random float, and RF, and we're gonna get multiplied by 2.0, then minus 1.0, then the random figure again, random float, and same thing. So we're getting a random random vector 3, and we're gonna apply this to the apply impulses vector 3.0 RND multiplied by 3. And then we're gonna clean up the timer by doing this, which is going to be var t is equal to timer dot new, timer dot one shot is equal to true, t dot wait time equal to 6, then t dot auto start true, t dot connect timeout function to the queue free function, and add child. This is what this simply do is since we're creating falling pieces, we don't want to make them keep falling in to oblivion. We just want to make them fall off the screen. So creating a timer, and whenever the timer is timeout, we're just gonna call queue free. Then we're just gonna create a simple function which is literally just optional, which is this function, and I've pasted the code, the smooth camera flow function. And what we're just gonna make the camera follow the top tower slowly. This is kind of an optional thing. You can use your own camera controls. This is just a makeshift system to kind of make it work, and if you have a really wide view, you will need that. Just a simple thing. Again, another function which is this update camera intermediate, which is literally just to update the cameras immediate in case the block moves. So this is all just makeshift system for a simple camera system. I recommend you try and work out your own camera system, or use something like the phantom camera add-on, which I'm not using, but actually it's just a really amazing way to create better camera movement than I could ever teach. So this is just a simple implementation. You need to create your own camera implementation. Then at last, okay, now let's also go ahead and call some functions. We're gonna call the update the intermediate camera immediately function in the start when the game starts. So sheesh. So ready function, and in the game start function we're gonna call the update camera immediately function. And then also here in the function here of the spawn moving block function, we're gonna also call the smooth camera flow function. So yeah, now after all of this, I'm gonna save it all. I'm gonna go to the HUD scene. So in the HUD scene, I'm gonna go to the 2D, and we're gonna start by, I'm gonna delete the HUD scene, and I'm gonna create a canvas layer. I'm gonna name this one HUD. Add the score label, or just label. I'm gonna call it score label, and you can just type some text like score dash or 1 dash 0 to actually kind of visualize what we are getting here. Then we're gonna go to theme overrides, and what I'm gonna do is you can go to downloads here. And here I did get some fonts. I got them on desktop. So I have this font called Leo Regular, I don't know, and I'm gonna go to the school label, and I'm gonna theme overrides, and in fonts I'm gonna just drag and drop here again. So got this. You can of course just go to this and font size, and we can just increase the font size to whatever we want, just to size, reasonable size. And yeah, I guess this looks quite nice, and I'm gonna place it right here in the center above here. Then we're gonna add a VBox container, and I'm gonna make this centered, and I'm gonna add a button. I'm gonna type text as START. I'm always bad at spellings. And again, theme overrides and fonts, and I use the same font, and you can just go with font sizes. Font size also increases the button size kind of. So yeah, that's it. I'm gonna go with this. I'm gonna add a text label here right above it. It should be here. Okay, and in the label I'm gonna type game over pal, and yeah here. And again, theme overrides font, and I'm gonna type this, and for size, oh sheesh, yeah, that'll do it. And I'm gonna hide both of these, since we're gonna make them visible through code. And I'm gonna add a script for this HUD, and we're gonna save this script in the code folder and create it again in the here. I'm gonna reference them. I'm gonna add the scroll label, then we're gonna add the game over text label, and then we're gonna add the button. We're gonna create a signal which is restart press. Then in the ready function, we're gonna restart button. We're gonna connect the on restart press to which we're gonna create. So function on restart press, we're gonna emit signal restart pressed. Then we're gonna update the score, which is gonna be this function. We're gonna give it score through the game, and this is just gonna update the score. Then we're gonna show game over by doing this. We're gonna create the show game over function. We're gonna make both of the label and the button visible, so the game over button and restart button. And finally, we're gonna create our reset function so we can actually reset stuff, so everything can go back to 0. Back in our game scene, we want to make sure that we have the reference to the HUD in the canvas layer. And also the HUD scene is actually added. I'm gonna save this as the HUD scene, and I'm gonna delete this one, and control this to actually add the HUD scene here. Make sure we have the reference to it. The name is correct. Then we're gonna go down here, and when you scroll down, you actually have to add many places. You will need to add the references and implement the code for the updating the score. Actually, first of all, we'll go into the game over function, and we'll actually just see if HUD, and HUD has method show game over, which we created. We're gonna show game over. In the ready function, we're gonna if HUD and HUD has signal restart pressed. What we're gonna do is gonna HUD.connect restart press to call the ball, which is the start game. This means whenever we press the start button, it's gonna restart the game. In the start game function, we're gonna call the HUD.reset. So when we start the game, the HUD will reset. In the restart game function at the end, we're gonna also call the update score. So when we start the game, it's gonna update the score. In the process function, we're gonna call the HUD.update score function, so it keeps updating the score. Actually, let's just do it in the drop function. So whenever we drop the block, we're gonna update the score. Actually, let's just we're gonna doing this in the drop function, and that's it for setting up the HUD. We should be able to go to the game scene. If we haven't messed up anything, we should run the game and we should have a game. If we press the spacebar, it's gonna stop, and you can see it's slicing and dicing and slicing and oh sheesh. Now if you do want all of the blocks that are falling to be actual collidable physics objects, you can just turn off the bottom ones here into actual rigid or static bodies, which can be done by going to the block scene and adding a static body node and making, since it acts as a unique name, we can easily just do that. But the problem with that is, let's just go to the game scene, and so if we do something like this, see, now they are sitting on top of each other. Awesome. This way you can have the effect of them sitting on top of each other. Of course they will despawn after some time, but you can just kind of have a you can just kind of disable that for. You can add something like collider down there, so if they collide with that, then they're gonna despawn. But I think this kind of a 3D effects looks way better. So cool. Them despawning over time is actually really nice as well. And yeah, that's kind of it for this video. I know this was a long one. There might be some issues with my explanations, but the game we created is so awesome and so fun to play. I've been playing it for hours at this point. And let me know what's your score if you ended up creating this game. How far can you go? I've been able to go up to like 8. My score is 8. If you can beat that, yeah, I know you can. I'm really bad at games. And yeah, that's it for today's video. And oh shit, I should have. And I'll see you in the next one. Bye bye.